29, systems of nonlinear equations. So generally for this, you can't use the graphing method. There are some instances where you can, but generally speaking, because they're nonlinear, you can't use your calculator again because nonlinear, which means it can be done, but it's just a little bit trickier to get it into your y equals. So here this says solve the system by substitution. So what I would do here is just use equation one to solve for x or y, and you substitute it into the other. So if we have equation one, equation two, let's say equation one has y equals x minus 3, then I'm just going to pop that in for x for equation two. So 2 says x minus 3 quantity squared plus y squared equals 9. Also of note, with these, because they're nonlinear, a lot of the times we are going to have more than one solution, meaning we might have two ordered pairs or three ordered pairs, right? Four ordered pairs. It just depends on the type of equations you're given. So just be prepared for more than one solution. All right, so here recall that this then, oh, hang on, that's not for y. For y, my goodness gracious. See, this is why I need y'all, so I don't do this squirrely stuff. Okay, 2. X squared plus x minus 3 squared equals 9. So x squared plus, remember, this is distribution over here. I'll do it in blue. X minus 3 quantity squared. Remember, that gives us the trinomial of x squared minus 6x plus 9. Right? Because this is x minus 3 times x minus 3. But you have to distribute, or AKA FOIL it out. So it's x squared minus 6x plus 9, and then equals 9. So what happens with the 9s? Yep, they cancel, because minus 9 minus 9. And then how many x squareds do we have? 2 x squareds minus 6x equals 0. And ooh, look at that. We love this, right? Because this is a quadratic, and what do we love quadratics equal to? 0. Perfect. Okay, so they both have a 2x in common, right? Both terms have a 2x in common. So when we factor those out, we're left with a 2x and an x minus 3. So that means that x is equal to 0 and 3. Right, we set each equal to 0 and solve. But are we done? No. Almost, but not quite. We got to go back and find our respective y's. So note again, see, we have two x's, so we'll have two y's. If y is equal to x minus 3, then for x equaling 0, we have that y equals 0 minus 3, so that's negative 3. So this is the point 0, negative 3. If x equals what, 3, then from here, right, this says that y equals 3 minus 3, which is 0. So from these points, we have 3 comma 0. So we have two solutions, 0 comma negative 3 and 3, 0. Part B says to graph the two equations to confirm. So I want y'all to pause the video and try it yourself and press play when you're ready. Okay, let's see. So I've got y equaling x minus 3. So that's negative 3 up and over, up and over, up and over, right? Essentially just the identity lines moved down 3. So there is the equation 1. And remember, the second equation is a circle with a radius of 3. So out 3, up 3, left 3, down 3. Okay, so go back to circles if we forgot that, right? Just go back to the circle section, refresh your memory. And again, so here we see 0, -3, and 3, comma 0. Yay! Confirmed. Okay, so now solve this again, solve the system using substitution. So I definitely want you to pause the video and then play when you're ready. So in this case, I would just say, I would go with my equation 1, E2. Say that now x equals 3 plus y, right? I just adding that y over. And then this time I really am going to substitute in the 3 plus y in for x. So equation 2, I have 3 plus y minus 2 quantity squared plus y plus 3 quantity squared equals 4. And then we'll just work on simplifying. Oops, sorry, forgot. I'm kind of wonky off screen there. There we go. Let's see. So 3 minus 2 is 1. So this is really just 1 plus y quantity squared plus y plus 3 quantity squared equaling 4. Remember that these are perfect square binomials, so they FOIL or distribute out to the trinomials. 1 plus 2y plus y squared plus y squared plus 6y plus 9 equals 4. Then again, this is just a quadratic. We're used to seeing it in terms of x, but we just have it in y, no big deal. And what do we love quadratics and equal to? 0. So I'm going to combine all my like terms. So there's 2y squared, and then 2y, 6y is 8y. And then I have 1 plus 9, which is 10, but subtract the 4, so that's the plus 6 equaling 0. So we distributed, aka FOILed, combined, it's got this term, or this line, combined like terms, and then moved the 4 to the left to get equal to 0. So now every coefficient is divisible by 2, so we're going to factor a 2 out. You don't have to do this. I just like it a lot better when my square term is not attached to a coefficient, is a 1. And then let's see, a y squared plus 4y plus, oh, that's not a 6. What is that? That's a 3. Look at me learning. Okay, so this factors into a y and a y. What two numbers multiply to 3 but add to 4? 1 and 3. So then my y equals the two numbers of -1 and -3. But are we done? Almost. Now we got to come back up here to find our x partners. So if y equals -1, then x is equal to 3 plus -1, or 2. So that gives us the point 2 comma -1. Again, remember that this is ordered pairs. So x is first, the y is second. Don't let that trip you up. Don't say -1, 2, because that's not right. And then let's see, y equaling -3. So from up here, equation 1, we have that x equals 3 plus -3, which is of course 0. So then we have 0 comma -3. So here are the two solutions. Again, this is very similar, right? This is a linear equation. We could also say that it is just, if I add the y over, subtract the 3, that is just x minus 3 equaling y. And then this is a circle with the center at 2, -3, and a radius of 4. You can graph it to verify. Oh, look, we are going to graph it to verify. Look at me. So again, here, this just says x minus 3 equals y. So minus 3 up and over, up and over, up and over. Do. Combine. Combine, combine, combine. There we go. Connect my dots. We have a center at 2, -3. to -3 and a radius of 2. Let me change colors for visual effect. So up 2, down 2, up 2, down 2, left 2, right 2, and then just combine, right? Because x minus 2, quantity squared, plus y plus 3, quantity squared equaling 4. Remember, it says the center, right? You just change the signs to -3, and you square root the last number to get your radius. And again, 0, -3, and 2, -1. Yay! Go us. All right, last page, y'all. You're doing so good. So now solve the system using elimination. Oh, and look, it's set up so nice for us. It's set up already so that what happens with the y's. Yeah, we can just dive straight into adding down. Because when we do that, what happens to the y squareds? They cancel. So it's just 2x squared equaling 26. So then x squared is equaling to, oh gosh, what is that? 13. So x is equal to plus or minus root 13. How fun. Okay, so remember cobwebby stuff. Whenever we take a square root, what can we not forget? The plus or minus, right? We can't forget the plus or minus when we take a square root. But are we done? No, not quite. So we go back and we can use either version. It doesn't matter. Well, I'll just use the top one. X squared minus y squared equals 1. So we go back to equation 1 and say, okay, well, if x equals just positive root 13, then this says that root 13 squared minus y squared equals 1. So this is 13, right? A square root times a square is just the number inside, minus y squared equals 1. So negative y squared is equal to what? Negative 12? But negative, that just says y squared equals 12. So then y is plus or minus the square root of 12, but that's plus or minus 2 root 3. Why, you say? Well, remember, when we take a square root, we can't forget the plus or minus. And then remember that 12 is 4 times 3. 4 is 2 times 2. So we take out one representative pair, right? One representative pair. All right, so this says that we now have 2 points. We have root 13, comma, 2 root 3, and root 13, comma, negative 2 root, 3. Right? Because x has 2, now y has 2. And then guess what? When we do negative 13, we're going to get the same thing. Watch. I don't want to mess with the 0. Well, no, it's fine. I'll still use the first one. So if x equals negative root 13, well, now it's the negative getting quantity squared. And what's a negative squared? It's just positive. Okay, so this now says the same thing. 13, I'm going to flip-flop these if you don't mind. Minus 1 equals y squared. So I subtracted the 1, added the y, so I don't have to mess with this pesky, annoying negative. So again, 12 equals y squared, but as we already established, that is plus or minus 2 root 3 from above. So like I said, now we know that also we have the next two. Negative root 13 gives us positive 2 root 3, and negative root 13 gives us negative 2 root 3. So here we actually had 4 solutions. Isn't that cool? Because this is a hyperbola, which are basically, let's see, this is minus equaling 1. looks like this, okay? These are branches that open apart from each other, okay? While this is a circle. So pretend like first I can draw, but basically you have, oh, it kind of looks like a basketball. Basically, you have the four corners, okay, where the hyperbolas are opening outward and where the circle uh, intersects. If you can graph it, it's pretty cool. All right, last one. Solve the system. So definitely I want you to pause and try this on your own and come back when you're ready. Okay, so again, if we label equation one, equation two, again, I would just run a negative through equation two so that when I add down, those y's disappear. So basically it's one minus two. So equation one minus equation two times they were adding. 4x squared plus y squared equals 13. Minus x squared minus y squared equals negative 10. So again, notice that those y squareds cancel. And then this is 3x squared equals what? 3? Yeah. So then x squared equals 1. So then x equals plus or minus 1, right? Because we square root both sides. And what can we not forget? When we square root, the plus or minus. But again, here, are we done? No, we got to go find our y's. So if x equals negative 1, I'll just use equation 2. This says negative 1 squared plus y squared equals 10. So this says 1 plus y squared equals 10. And then we subtract the 1. So y squared equals 9. So y equals plus or minus, oops, excuse me, 3. Because how do we go from y squared to y? We square root both sides, not forgetting the plus or minus. So 2 points that we have are negative 1, negative 3, negative 1, and 3. Next, what if x equals 1? Well, guess what? It's plus or minus 3 again. 1 squared plus y squared equaling 10. 1 squared is 1 plus y squared equals 10. And then, it just flows from there. So y squared equals 9, square root both sides. So y equals plus or minus 3 again. Whoop, because we are just square rooting both sides, not forgetting our plus or minus. So then again, here, let me go back to purple. We're almost done, y'all. Thanks for hanging in there with me. That's 1 and a negative 3, oops, and then a 1 and, oops, the positive 3. So again, we have all 4 equations. Because this would be an ellipse. Hey, if you take pre-cal, you'll know more. This would be an ellipse, and that is a circle. So essentially, let's see if my memory serves. Center. Let's just say it's this. Whoop. And it doesn't look like this, but just bear with me. Okay. So again, you just have those 4, and oh, you can't see. Oh boy. You just have those 4 intersecting sections, but you have basically an oval that is laid on top of a circle. Cool beans. That's it. So that is all of section, what was this, 29? Yeah. All right, now I gotta figure out how to stop. Okay. Bye.